The James Webb Telescope is a collaboration between NASA, the ESA, and the CSA. Launched into space in December of 2021, it has proved to be a significant breakthrough in science, space technology, and astronomy. The James Webb Telescope primarily aims to find the earliest galaxies formed in the ancient universe and to see stars developing planetary systems. So far, the James Webb Telescope has unveiled some of the most mesmerizing discoveries ever. Recently, there has been news about a new finding by the JWST. What could it be? Is it aliens this time? Well, let's find out. Hello guys, and welcome back to Space Unearthed. The James Webb Space Telescope has observed one of the most oldest galaxies formed after the Big Bang, about 340 million years after the universe started. The galaxy called Glass Z12 and another galaxy that was born about 440 million years after the Big Bang was found over the summer, just after the Strong Space Observatory began its infrared sightings of the cosmos. Webb's capability to look more in-depth into the universe than other telescopes is expressive of previously hidden aspects of the universe, which includes astonishingly distant galaxies such as these finds. The center of operations for the telescope is located in Baltimore City at the Space Telescope Science Institute inside of the Johns Hopkins campus. The discovery could transform the way astronomers understand star and galaxy formation in the earlier days of the universe. Quote, "With Webb, we are surprised to find the farthest starlight that anyone had ever seen just some days after Webb released its first data." End quote. This was told to us by astronomer Rohan Naidu, a research fellow at the Massachusetts Institute of Technology. Naidu was the chief author of a November study issued in the astrophysical journal Letters. Previously, the oldest galaxy observed was GNZ11, which came into existence 350 million years after the Big Bang and was seen by the Hubble Space Telescope in 2016. Quote, "As soon as we began taking data, we found that there were many more galaxies than we were expecting." End quote. This was a quote from Tomasu Trell, professor and principal investigator for the GLASS JWST Early Release Science Program. Quote, "Somehow, the universe managed to create galaxies earlier and faster than we thought. Just a million years after the Big Bang, there were already large numbers of galaxies. JWST has started a new frontier, bringing us closer to know how it all began, and we've only just begun to explore it." End quote. This is also a quote by Trell, who is also the co-author of the astrophysical journal Letters. The journal studies have been published. These discoveries were made during the GRISM Lens Amplified Survey from Space, also called the GLASS, and the Cosmic Evolution Early Release Science Survey, or CEERS. The early galaxies found in the new cosmic frontier are unusual and surprising to astronomers in a lot of ways, Trell said. Both galaxies have a sphere-like shape, and they're just a smaller percentage of the measurements of the Milky Way galaxy. The galaxies are too distant, but they're also very bright and form stars very rapidly. The research findings have proposed that galaxies may have started appearing in the universe just 90 million years after the Big Bang, which happened 13.6 billion years ago. This timeline summons theories astronomers have held about when and how the first galaxies were formed. The early universe was crowded and chaotic, but the structure of the two galaxies seemed calm and orderly, stated Erica Nelson, assistant professor of astrophysics at the University of Colorado in Boulder, who is the co-author of the November study. The amount of brightness in those galaxies has puzzled scientists. One likelihood is that the galaxies were huge and contained many low-mass stars, which is like the kind of galaxies that formed later on in the universe. Or it can imply the opposite, smaller galaxies with fewer but really bright stars. These luminous things, called population 3 stars, have been theorized as the first stars ever created in the cosmos. The initial stars in the universe would have been really hot and only made of helium and hydrogen. Later stars contain heavier elements that were formed when the first stars exploded. So far, not a single population 3 star has ever been seen inside of our local universe. But telescopes that can look back into the distant universe, looking back effectively in time, may be able to view the first population 3 stars one day. The older of both galaxies, Glass Z12, might even contain population 3 stars, said Adriano Fontana, a co-author of the October study and the member of the Glass JWST team. And the latest findings about both galaxies might mean other bright galaxies are waiting to be found in the near universe. The distance measures of the galaxies are based on the Webb's infrared detection. Follow-up spectroscopic monitoring can confirm how long their light has been widened across the universe, as well as the rate of which star form in each galaxy and the elements of these stars are made of. Webb's near-infrared spectrograph will take the data that would lead to these insights. Quote, "These observations just make our head blast. This is an entirely new chapter in astronomy. It's like an archaeological dig and suddenly you discover a lost city or something that you didn't know about. It's just staggering." End quote. This was a quote by Paola Santini, a researcher of the National Institute of Astrophysics' Astronomical Observatory of Rome, who is a co-author of the October study. The Webb telescope has stepped into its 5th month of science operations and has proven to be strong in capturing sharper pictures than pre-launch expectations, said Dr. Jane Rigby, Webb Operations Project Scientist. Quote, "These galaxies we are talking about are bright. They were hiding just under the edge of what Hubble could do. They were waiting for us. We just had to go deeper than what Hubble could do." End quote. From the image created by NASA, the James Webb Telescope essentially covers a really big part of the infrared spectrum, much wider than the Spitzer telescope and something that the Hubble was never able to do well either. This is, of course, super important because a lot of these super ancient objects, the objects that very likely looked extremely bright, produced a lot of different types of starlight and emitted a lot of different types of energy. Their red light shifted so much that all of this visible and even ultraviolet light became extremely redshifted and now appears to us as infrared light, with some light even reaching the microwave spectrum, which of course means that we're not really able to see between these galaxies with a typical telescope such as the Hubble telescope. However, the James Webb can see them really well, and more specifically, it's able to directly observe that era at the beginning of the universe, often referred to as the Dark Ages. When the stars had just started forming the galaxy and started to develop, the universe was still not particularly transparent, something that started approximately 375,000 years after the beginning of the Big Bang expansion. But it's most likely to end within 1 to 1.1 billion years, and so during that time, things were not particularly clear, and so it's all actually kind of difficult to see those things and to study that particular part of the universe, but this telescope makes it slightly easier. As a matter of fact, as this recent study discovered, it makes it a lot easier, and so the scientists behind this paper with the title 2 remarkably luminous galaxy candidates at redshift 11 to 13 revealed by James Webb Telescope pretty much tells us exactly what this paper is all about. First of all, it reminds us that we've only discovered one single galaxy at a first-rate shift of over 10 when the universe was approximately 500 million years or younger, and that's, of course, the GNZ 11 galaxy. But second of all, they're able to discover not one but two separate galaxies at ridiculously far away distances of redshift 11 to even redshift 13, which officially means that this galaxy is no longer the furthest ever found. It's not a tiny blob. What is this new galaxy referred to as Glass Z13? Why glass as well? It's actually the name of the survey or the early release data from the infrared imager on the top of James Webb Telescope that released all of this data approximately a month ago, somewhere in mid-June of 2022, and somewhere in this data the scientists realized that some of the really ancient powerful light was actually being absorbed by a lot of the neutral hydrogen that used to exist in the early universe and ended up absorbing a lot of light that we just cannot see anymore. Nevertheless, by looking at this data from the James Webb, they were able to discover several patches where something was clearly being absorbed by some kind of ancient radiation because, in this case, the emissions that were being absorbed were very likely what's known as the Lyman alpha emissions, or the emissions of hydrogen usually coming from extremely powerful galaxies that we've seen in a lot of different places. In this case, by using all of the data, it became possible to work out the redshift to these really far away invisible objects, with one of them being a little bit closer to us than compared to the previous record holder, and one of them being super far away. The distance in this case would be about 33 billion light years away from us. With the universe only being about 300 million years old, that's actually a time when the stars would only have started forming, and so naturally this represents some of the earliest universes we've ever observed. And with that all said, we come to the end of today's video. What do you think about this new discovery? Do let us know your opinions in the comment section below. If you liked the video, then give us a huge thumbs up. Also, make sure to subscribe to Space Unearthed and press the bell icon for more updates. We'll come again with another video. Until then, goodbye.